So in today's lesson, we're going to talk about polar equations and their graphs again. This time we're going to try to identify, kind of like we already have, some of the um, standard form equations and what they would look like. Now we're going to get into a few more particulars of these equations and their graphs in our next lesson. So for today, we're really just concerned about learning about the names and a little about what these points or numbers would do to each of the graphs. So this first set are called limicons. And in our limicons, we're going to have a number plus or minus, and then another number cosine of theta or sine of theta. Now, the sine and the cosine, just like we did with our circles in our last lesson, are going to help us determine the axis that they're graphed on. So if it's a cosine, which all of these would be cosine graphs because they're graphed out to the right, they're actually all positive cosine graphs. The number in front is positive. If they were sine graphs, they would be going up, and these loops and circles would be down here at the bottom. So positive and negative, we'll talk about all of that again a little more in our next lesson. But if they are in this form, then there are four possibilities of things that could happen, and they have to do with these numbers a and b. So if a divided by b is less than 1, if it gives you a fraction less than 1, then you end up with this limicon that has this little loop on the inside. So a limicon with a loop. If a divided by b gives you 1, if these are the same, like 2 and 2, 3 and 3, then you're going to end up with what's called a cardioid, or it's supposed to look kind of like a heart. I know it doesn't have a point out there, but it's kind of like a heart shaped. Comes into a point. If a over b is somewhere between 1 and 2, if this fraction is somewhere between 1 and 2, you get a dimpled limicon. It's kind of just got an indentation on this side. And if a over b is greater than or equal to 2, then you're going to have convex. It doesn't sink in on this side. So those are all limicons. There are 4 different types. And we'll talk about also how a and b will help you determine how long this part is, how big the loop is, etc. in our next lesson. All right, next we have the rose curves. These are my favorites. The rose curves are going to be in the form a cosine of n theta or a sine of n theta. So a is going to determine how long these leaves or petals are on the curve. So on all of these, a is just how long the petal is. If it's a cosine graph, the petals are always going to start, the initial petal, the first petal will be on the positive x-axis. If it's a sine graph, the first petal will be on the y-axis if n is an odd number, and it turns out that it's on the line y equals x if n is an even number. So let's talk about this even and odd thing and what happens. N is just the value in front of your angle. And so if n is odd and you have a cosine graph, you're going to end up with an odd number of petals. If n is even, then those petals, there's still those same petals, but they double. It goes around one more time and you end up with more petals. If n is odd and it's a sine graph, like I said, we're going to start up high and we end up with this odd number of petals. If n is an even number, we end up with an even number of petals. So all of these are just rose-shaped curves. They are sometimes called petals or leaves that they form. They're really fun to watch them graph on the calculator. All right, this last section here that we've got circles, which actually we've already graphed on our own. We didn't use a calculator to graph those. We talked about how to figure these out. A is going to be the diameter of your circle. If it's cosine, it's going to go to the right or to the left. If it's sine, it's going to go up or down. And then these last two are called lemniscates. And this is the form of a lemniscate equation. So if it's a sine, then it's on the diagonal y equals x. If it's a cosine, it's going to be on the x-axis. The limit skates on the x-axis. All right, so let me just go back up to the ones that were the rose curves and kind of give you some information you may want to write down about those. We'll get in more depth again the next lesson. But if n is odd and we have a cosine curve, then A is on the x-axis. It begins, the first petal or leaf begins on the x-axis. If n is even, we're going to double the number of petals. A is still on the x-axis. If it's a sine graph and n is odd, then we're going to start on the y-axis. And then if it's a sine curve and n is even, then we're going to start on the diagonal y equals x. Okay, so today we're pretty much just going to need to be able to identify the equations and the graphs that they would form. All right, so we're going to take a look at how we can graph these on the calculator today. So this tells you what we need to do. So we're going to go into the mode screen, and you want to highlight degrees and polars because they're going to give us our angles in degrees today. So degrees and polar. Now, when you go to y equals, you notice that instead of it saying y equals now, it says r equals. Well, remember, all of our equations are r equals in the form r equals. R equals a plus b cosine of theta, r equals. There's r equals. R, even the circles we already drew, r equals. And this one, you could take the square root and have r equals. So the y equals has been replaced with r equals. We can use the same button that we normally would use for x for theta. So you notice this key has other labels on it. This is why, because it depends on what mode you're in. So we're just going to type in we are going to go ahead and set our window. So let's go to our window. We're going to go from 0 to 360. We're going to step by 15 degrees because that's what's in the table down below. So, like it says, the x and y values are going to determine how big our window is. So for our polar coordinate grid down here, we're going out 1, 2, 3, 4, 5. So if you only want to see those 5, you could go out 5. So I think I'll go here from, I'll just go a little bit bigger. So -6 to 6 and -6 to 6. All right. Okay. So we're going to put in our equation 2 sine of 3 theta and take a look at the graph. All right, so we get one of those. We should already have known because of the equation, but we get one of the rose petal graphs, and it has 3 petals or leaves. All right, so let's write that in here. We get a rose curve with 3 leaves or petals. All right, so they want us to actually try to sketch this. Now we kind of see what it looks like, but we're going to try to plot it for ourselves. And so they've got a chart for us to fill out down here. Since you already got your equation in, you can just go to your table setup, put it back on auto because we've already asked it to step by 15. You may want to put that in here as well. And oops, hold on. We need to start that at 0. There we go. 0 going by 15. So make sure you can see that. 0 going by 15. And be sure that we change that back to auto. And then you can just fill in the numbers. So at 0, we have 0. 15, we'll just go one decimal place because we're going to plot them. 1.4, 2, 1.4, 0, negative 1.4. So you can just copy them off of your table. We're going to get negative 2, negative 1.4, 0, 1.4, 2, 1.4, 0. At 195, negative 1.4, negative 2, negative 1.4, 0, 1.4, 2, 1.4, 0, negative 1.4, negative 2, negative 1.4, 0. All right. So we're going to try to plot a few of these anyway. So let's take a look. So 0, 0, right in the center. Then we're going to go out 1.4 and around to 15. And then out 2, 1, 2, and around to 30. And then out 1.4 again, this time to 45. And then 0, 60. And then we've got negative 1.4, 75 degrees. Negative 1.4 would put us at 255. For 255, right in here. Negative 2, spin around to negative 90. Negative 1.4 again, negative 105. And then 0 again. All right, so we can kind of see here's a petal, here's a petal. So it did this one first, right? When you graph it on the calculator, if you'll watch it, it'll do this, and it'll come down here and do this. So we have one more petal left, so let's see what we got. We got positive 1.4, 135. Positive 2, 150. Positive 1.4 again, 165. And then 180, 0. So we went this way, down, and now it comes back up to here. And those are our petals. So what does all this do? Well, this just doubles up. So I'll just show you a couple of these. If I go negative 1.4, 195 degrees. Well, that's going to be 180 plus 15 degrees. So 180 plus 15 takes me right back to this point. So all of these values are values that we've already plotted. It just replots them again. So it just graphs on top of itself. So whenever we said earlier that sometimes it doubles the number of petals, it doesn't really. It's just that these graph on top of themselves, so we only see the 3 petals, whereas some of the others don't graph on top of themselves. So today they're going to have you graph using the calculator, so you're welcome to use your Desmos if you'd like, but I think this one, maybe the TI could be better for you because of the table. I mean, you can just read it straight off the table, just scroll down and it'll give you all of your numbers as long as you have it set up the way that it says on the paper. So we're just taking a look at some of these polar coordinate equations and their graphs.